We are going to continue now with the speaking about architecture and development of complex systems. I spoke about this question before the event at a specific webinar for solution partners and also during the event on Wednesday morning. As I was saying on Wednesday morning, I made a presentation on this topic. And before this one, there was another one by Gaston Milano who was talking about architecture, leaving aside GeneXus. So this question has already been discussed during the event. Now I would like to make a summary in 15 minutes or so of the main points that were presented in order to refresh the question and then have a period of questions and answers. I thought that it would be better to do so and not to repeat the presentation again. When we develop with GeneXus, we like to see reality like this. That is how we started, and that is how we work every day. But actually, this is too simple a reality to be analyzed and be able to learn something from it. Why is it too simple? Because the world is moving towards multiple experiences. So it's not going to be one web app, but several who do it. And the world is going from enterprise solutions to ecosystem solutions. So our systems have to talk with others, and we will create several systems that have to have a unified vision and experience for the user. Our systems will become more and more complex, and they will interact with many entities or subsystems. This is obvious when we look at the architecture of everything we can build with GeneXus, the different solutions and the multiple experiences we can create with GeneXus, or when there is a new development of an ERP or something similar that has various models or subsystems, models in the large sense, complex models of a solution. Today's world is accelerating the rhythm of development of you have will require more in the future. So the question is, when are we going to build a system? This gentleman said that the quick question is, how often do you need to release what? And based on this, we can deduct things with regard to the architecture and the work teams. So these subsystems, how often do they need to be released, and how am I going to build a team around the systems and the systems, and what will be the architecture based on that decision? So let's see something about architecture. When Gardner speaks about architecture, and we hear others speaking, people talk about microservices as opposed to monoliths. And there was a very strong trend and a lot of hype around microservices. There was a strong push towards microservices. Last year, when I went to San Francisco, people were already coming back. They had gone to the extreme of making the services so micro that they got scared and said, well, they should not be so micro. The complexity is growing too much, and everything becomes so complex that we lose a general vision of problems. And that's where a lot of problems come up. You have to be careful with things that are extreme, like in all fields. So we develop systems that are complex in data and where the data are the most important asset of the company. So in our case, we have to be extremely careful with these hypes and things they wanted to impose or on us or sell to us. And we know that we are working with applications where the data are a fundamental component, and consistency is indispensable in many of the modules of the system. Maybe not in all of them, but in some of them, consistency will be fundamental. So this is a simple structure that we can build a monolith, and inside a web app, and based on a database, we create this in one machine or the other, but all this is a database and it's a web application. This is very easy to do. We have the control from this KB of everything I do, but it's all or nothing. The performance is all or nothing, and the scalability is all or nothing. The application dies, and in the reorganization of the database is all or nothing. So we started separating. I keep a database in the KB, and each one of the subsystems is another web app. So here I can do deployment of this one without touching this other one, and it is more limited to the update and the problems that may come up. If something stops working, I know that I have to find the problem here, search for the problem here, but at the level of the database, it's still all or nothing. So if the users of this web app in some way have to see data of pay panels here, well, no problem with the data, but with the panels of the web app, in this web app, I have to see how we do it. Either I show here an embedded page of the system, or I make the user pass from this web app to this other one. In any case, when he sees the panel, he has to move from web, or when he moves from one web app to the other, I have to start controlling the matter of the sign-on, and I'm not seeing a web session unless I have a web session application. I'm not going to have the same web session here. Another matter is that before we go to the microservices, I'm working with a KB, so here I can have access to the tables of any of my subsystems I do for each, and I work well in everything. Now let's assume that I am going to a scheme of microservices. I separate the KBs, and each one manages its own tables and indexes. So they are two independent systems with a simplification at the level of the deployment. They are going to a same server of databases, or they are in two different schemes of the same database. In this case, since there are two different uh, KBs, I can't do a for each. So in order to be able to do a for each for these tables, I need somehow to take the structures from one side to the other. And this is going to be important. It's important to coordinate this and that it is automated, so that when the structures of these transactions are changed, they are replicated on the left-hand side, because otherwise I'm going to have an impact on these tables on the right, and the programs on the left will stop functioning. So here the updates and the DevOps will help us keep the system synchronized. In these transactions, you have forms and you have rules and formulas. If I take the structure of the transaction, that's what's usually done. Sometimes here the transaction is duplicated in order to have one that has only the structure, and then you export the structure to the left. And here the data views are created so that this system does not impact the tables on the right. So what do achieve in this way? We have a for each and we can do a join between the two tables. Now, what's the problem? If the programmer does a new here, maybe he's introducing new data, but it doesn't go through, they don't go through the business rules that are programmed in the original system. So what was invented in GeneXus 16 upgrade 5? Have modules. I can package a module in the original KB and take it here. So here come the interfaces of the module and the binaries. The binaries come here too when I do the deploy, and I have the modifications of the business component, which will be calling this on the right, these tables. So now, if I insert data through business components, I am forcing the enforcement of the business rules. What do people do? Usually, they do both things at the same time. Through a methodology, through a convention, they stipulate that all the modifications or the deletions, etc., should be done through the module, and the reading for each are done through the transactions. I bring the transactions in order to be able to continue having for each and join for the readings, and I have the modules for the deletions or the inclusions or the modifications. This is what they have at the moment. In GeneXus, we don't have a way still to force the for each program here to be just for read only, that you have to do with a methodology or with your own tooling or by teaching your programmers not to do the other thing, or with the use of the database. Yes, some forcing it in some way. He said that in the database, the user of the database, I'm sorry, he's not using the mic. What I mean is the user that is connected to the database of KB1 has access of read-only to the table, but I don't know how the module solves it. Well, in the module there are binaries that are generated, but this module uses the same web.com that the other one, that the rest. I don't know how you would do it. What I have seen is tooling, or not even tooling. Nowadays, you have it written on a paper. It's methodology. These are things that we still can do in GeneXus. Actually, we were asked to do it in the future. The other tooling that's here is the export of the transactions so that you don't have to duplicate them and create the data view. This is something on which we are working. Actually, in the beta, we already have an export. When you go to the export dialog, it's possible to export only the structure of the transaction that has been thought for this scenario, but we still have to polish it more, and it will come later. These tools will be in GeneXus. If the module has a data store and the data viewer have another data store, the user can make the solution. Well, so far I have consistency in the data. I, the tables are not duplicated. Everything is consistent. The problem comes with the data that may be consistent or not. In micro times or in seconds or in hours, it could be seconds. There is data that are different in one place and in the other. Sometimes this is of no consequence. For example, in Netflix, someone published the film in the back office, and it doesn't matter that we, the users of Netflix, during that second, don't see that movie yet, but we will refresh in 5 minutes, and we will see the film. There's no problem if there is inconsistency in the data. But things are different when in the same system I have paid, for example, for something that appears as paid in the back office and is not paid or something like that. It may happen that the databases are different, but I start replicating data because of a question of performance. Until now, in the previous case, they were both close to each other. They were in the same database in different scheme. Now I'm going towards a scheme in which the systems are running in another country. So from this web app, I cannot have access to this database because there's a question of latency. I cannot access this database with a select. So what do I start doing? I start replicating some data for a question of performance in order not to be asking all the time for the data. So I replicate here the table of employees, for example, in a human resources system. What happens when I do this? If I have the same table in two places, I have to define always who owns this data. And from then on, the rest is triggered. If this is the owner of the database with the information about employees, he knows that at some point he will have to find new data, and a protocol has to be defined for this update to be made. If every time he touches the employees table, he wants the rest of the system, or maybe they have to call him through a web service to find out whether there is anything new or notifications in between. And they also have to decide how often there are notices, or what happens if the notice that there has been a change comes twice. And for this synchronization mechanism to be simpler, some systems have been invented in order to make an event bus. That is to say, the owner of the data publishes the updates in the event bus, and all the systems that have to learn that there has been a change will consult the changes or will subscribe to the changes of the employees table and will take the relevant measures. And this is very good because the systems can scale independently. It's not that now 20 systems are going to be asking these systems through a web service whether there's anything new. There's a lower load on this system. Everything is delegated. And in this case, I don't need to know how many systems to notify because I notify just in this one, and everybody will know that this is where they should come to ask for information. So the systems are decoupled and can grow more independently. So what did we do in GeneXus for this purpose? With regard to the data layers, we used to have them in data store, but we implemented, for example, now read committed in the databases and in the APIs. We implemented one with Apache Kafka, which is a handler of streaming that can act as an event bus. We implemented sockets API. For example, sockets are used in chat applications so that when there is an update on the one side, they will inform on the other side. So levels, systems notify each other. Also, an API for login in GeneXus 16, that is to say, in line between your procedures, you can generate calls to the log API, and this go to log archives or files in the system, and then you will have agents that read those logs and send them to another system that afterwards allow you to do a search on the various actions of login for the purpose of monitoring or observability. With regard to the IDE, we implemented that the package module should also function on modules that have access to the data. We improved the uh, performance for large knowledge bases, and the deployment units are the ones that will allow us to make a deployment of the necessary components and sufficient unnecessary components for our web app. Each one of the deployment units in GeneXus maps a web app. And then we implemented a custom build, which is a new build command. You go to Tools, Options, and Build, and there's a custom build option. There you define a new build command that will have some subsets of all the tasks and the steps that the build follows. When you build or say rebuild all, it applies the patterns, saves the objects, and starts generating each one following the various steps, generates the STTs, compiles, updates the web.com, etc. So with this command build that you define, you can make it execute just some of these subtasks. For example, I define a build command that only executes the updating of the web.com field. So if I change log level at the level of the environment, that only affects the web.com field, I have defined a build command that does only this. What you do nowadays in GeneXus when you want to do this is in some way try to force the generation or do a build all. But if you're doing too many things, when actually I just want to update the web.com. Same thing if you want to generate all of the SDTs, you mark only the generation of the SDTs and the compilation at the end, and you do it like this.
En el AS
In IS 400, you can separate transfer from generation. And there are some of you who wanted to generate the code or touch it and then send it to transfer or to transfer it to S400. Now you can separate it. At GAM level, we have SAML 2.0, then new protocols that we support, and we have the SSO. And now let's move on to questions and answers. Any questions about these schemes or anything that you may want to know about this? Any questions? Is everything very clear? Or absolutely the opposite? All right. I don't know if this is much related to this, but thinking about complex things, is there a difference with GeneXus and blockchains and those things that are complex? Well, there are some companies that have been making concept tests against blockchain, and we haven't got, as far as we know, we don't have any customer in production doing that. So if there is any project that would like to move forward and make a concept test, we can send you the material in the beta version. We can have a beta store against blockchain, and we can send you, just send me a mail and I'll give you the instructions. In fact, next week, if we have enough time, we'll publish we'll make the publication about how you do it. In the meantime, I can send you something. I would like to point out two things about blockchain. There are two ways. One is to make a blockchain in premises, and you can program with GeneXus in relation to that blockchain. You add it as a data store, and when you make a for each or you make a new, you make calls to the APIs of that blockchain, and you generate the small contracts of the blockchain. Now, there are other blockchains that have already become commercial. They are commercial, and maritime companies already have that, where all maritime companies agreed on going against that blockchain. And the only thing you have to do is to connect to the REST service of that blockchain. There's nothing more than that, nothing more to that. And so there is no break in doing projects against blockchain. Now, do you have to have a hardware? Well, yeah, well, yes. Now, we don't solve the problem of that installation. That's a very complex issue. You have to solve it. We've got partners, uh, but, well, this is what we are supporting, Hyperledger. I've seen that many of the things that are complex have to do with the module thing, and that's what I expected from modules. Um, if you know the thing and you can describe it, well, you want to share this, or this is public, or whatever. Um, it's not a question of procedures and things. All the scenarios that you describe seem that it would be ideal that I could declare it in the modules and that everything is done automatically. Now, in the meantime, there is something to automate with Jenkins, start moving things, but it's not going to be the same. We're going to forget and have to go back because the programmer, um, uh, we are automating what can be automated. Well, there are two parts to that. On the one hand, you have to build on modules, and we have to add more functionalities to the modules, right? Now, anyway, even if you have a model, you'll have to automate not as much as you do now, but you'll have to take that module to the other KB, or you'll have to have an entity in the center so that when I update my module, it will be automatically published there in that center. And then the KBs that use the modules are also subscribed to that entity in the center that finds out that there is an update of the module, right? Um, in the world, this we have this question of source repositories, but also package repositories. Nexus is one of those repository handlers of packages, in the same way as modules are. We made an implementation. It's in channel beta, and we would like to move forward in relation to that. That is to have something that we call an knowledge matrix, and you're going to be listening to that. That knowledge matrix is based on a nexus, and the first scenario that will support is that you will be able to install a nexus in your organization, and you'll publish the modules that you can do in that nexus through GeneXus, an operation in GeneXus that catalog that nexus in GeneXus, and then you'll be able to publish your module in GeneXus. In other KBs or in other GeneXus installations, you can make reference to that nexus that you have with those shared modules. That's going to facilitate things. We would like to go along two lines there. The first one is to support that each one of you will be able to install your own nexus, but we also want to have a knowledge matrix, that we call it a central one for all the community, and perhaps several Some of them will be beta, others will be production, others by region, because components that you want to share are not the same as the components of the community here, or something that you want to share as the Latin community than what you want to share in Japan, for instance, where there are specific cases, or in Asia in general, or China, uh, which will require its own components. So you'll probably be seeing this under the name of knowledge matrix. It's based on the GeneXus. There is going to be a distributed network where there is going to be a repository of packages such as Nexus, and that's going to allow you to have a better possibility. Well, that KM, if we can call it like that, that KM, that knowledge matrix, if you want to dream, you want to make it have an impact, and what you're going to generate is not going the impact on the database and on procedure, but also what's going to happen with the KM and what's impact is going to have on that. And we go along the same line we've been working on, where GeneXus is in charge of the deep detail of relationships among all the things I've got, because I don't have large KBs, but those managing 20,000 objects, I really don't know what they do. In the case of Costa Rica, in the Ministry of Economy, for example, they will kill the programmer doing a rebuild all, because many objects. And now it's very dangerous to have a failure there because of all the things. And but then on the other hand, it's paralysis by analysis. And if you review the impact, then the speed we get through GeneXus on the one hand, you lose it because of lack of connections of this way, or wrong connections. Yes, uh, because this question of adding always the same to a KB is that we started teaching about architecture, and so that people modularize more. Yes, people say that you can't do this in GeneXus, and so on. Now, my question is, you said something about login, and there is a log object. Now, what's the difference between what you said and, well, it's a log API called log, the object log. It's like an external object called log, right? Now, it's important to think that we have more and more systems in the log, the various systems to record the log that can go up to a unified place, and I can automate it and see where failures come from. You have to make tools, you have to work on that, yes. Any other questions? Yes. Now, in the case of buses, where you have data management buses, have you thought about automating that, so I don't have to see which is the best handling of buses? There is one done here with Clínicas, but there are more primitive places such as Costa Rica that the bus we have is to go from one place to the other. That's a very old idea, as old as me. And it's very difficult to implement because each one has a different way of thinking, and it's better if you adopt something and it doesn't have an API, or because it would be easier. If it's descriptive, you put in the service, and the apps that you make will connect to the same bus. I don't know if I'm going too fast. The next century. Well, what we've got now is an API to connect to Apache Kafka. That's one of those handlers. And we know that there is certain experience in the community using it, particularly in the Panama Canal. Everything is done through Apache Kafka. they've implemented in all the premises and all systems. As the ship goes by, they have to report what is happening to the ship and to the bus. Well, it's a separate installation, but it's always a separate installation. Doesn't matter what technology you're using. That technology is an Apache. I mean, it's an installation that's apart. It's general, and then all systems will report uh, in different topics and will report that information. And all the systems that need it will read the news from there, the topics that they need, and they need to have information because you publish a topic, and then under that topic there are data. And then someone may be interested in a certain topic, would subscribe to that topic, and will listen to news about that topic. There is no added value of GeneXus in that event bus. Those are existing systems. Now, what we can do is to have better connections to that event bus. For the time being, we've got an API, and what we're thinking of is of for each, perhaps with a new, you could call that Kafka, but those are syntactic things in GeneXus. I was referring to that, not the way it works, but the fact that I could put in a panel and say this panel is communicated to. So I don't have to program that. Yes. Well, the web panel will be refreshed, will refresh on its own if there are any news. Right. Yes. Yes, we've got an entire specification about event handling, event-driven applications, but we haven't focused on it yet. But it's there. Yes. Yes, we have it as an event-driven application, and everything we have to do. Well, in fact, what happens is that if I put up a data in a transaction and there are others that subscribe, when that happens, for instance, I accept a bill and the accounting department finds out that it's been accepted. Well, there are systems that we put in some kind of chat so that users talk about it. But to talk about something that's transactional, well, it's like going backwards. They used to give you a little slip of paper, and now I send you a chat when, in fact, yes, yes, I understand. And I've got another question. Gaston said several times, not only in this event but in past events, that the world is not SQL, and if you aren't, well, you're losing the battle. But I think these are different things, and there are certain applications where non-SQLs are far more efficient than SQLs. So, discussing this with some people from GeneXus, I said, uh, I wouldn't like I wouldn't like to do this in the for each and do this for relational to something that is non-relational. But there are many things like those that you're talking about that are structure that would be much better there. Haven't you thought about doing something like inventing a command called retrieve or something that allows you to do that in non-SQL database instead of having to do all that from the outside? Well, in fact, we made a test to have a DynamoDB, MongoDB. We want to have it as one further store to simply do a for each as any database with certain restrictions, but you could program it on it. Now, each one of those database has its own purpose. As happens with Kafka, it has its own purpose, but it's streaming. Others that are for search, like Elasticsearch, there are others, different purposes. And what we want is that for each one of those purposes to have something native that can be connected um, on them. We haven't been able to advance on that this year, but we've made prototypes, and we would like to go along that line. Well, it's that we started talking about dynamic forms, and it has to do with GeneXus Consulting. But they said that the only way of making it efficient was to use MongoDB, and well, yes, roughly. I don't know. Well, Microsoft came up to say that now they are so powerful in their database that they could, a table such as attribute value, object attribute value, the sub-level. What I mean is, in this case of dynamic forms, sometimes we want to use for cases, if I have a transaction, let's say in insurance, the insured has certain properties about the age, as the assured, they know about my age, whether I'm a smoker or not, some of my features that have an impact on the risk calculation. Now we're learning more on that, and all that number of attributes is infinite. In fact, it's growing a lot. So I can't have one table of the insured. I've got the insured with a certain data, basic data, but then I have a sub-level with an attribute and a value for each things that occur as time goes by. So that table goes growing. So I have millions of insured, but then I have thousands of data or attributes or hundreds of attributes that are additional that multiply the whole thing. So I'm going to have many, many records there. And somebody may say, well, this table down here, the one that is basic, should go into one of these, MongoDB or. And then the discussion is whether it's really necessary to do that, or DBMS, traditional DBMS, can support so many data, and Microsoft came up saying they do. But do we think that it's necessary to add so that you have those data stored? We haven't got it now. Any other questions? Otherwise, we are on time. Last one? All right, no more. I haven't got anything to give away. I'm sorry. So, okay. Thank you very much.